All right. Seems like we're either getting stuck or distracted. So let's work this through together. Can't tell which one, but we're going to do it together then since we're getting stuck or distracted. So they give us this table of information, and they've told us which sides we need to label. So when we have our graph, bless you, we're going to have our selling price on the bottom, and it's the number of dolls on the Y. So we want to make sure that we can get our graph to be readable, but also detailed enough. So we like to fill as much of the space as we can. So looking at the data that we have, do I need to count the bottom of the graph by like ones and do like 1, 2, 3, 4, 5? Because we only have data up to the price of the dolls up until how much money? On our table, it only goes up to $4, right? So it might make sense to do a little bit of skip counting so our graph can spread out. Maybe we can get a more accurate estimate of things. So I tend to do maybe counting by quarters, like 25 cents. So 1, 2, 3, 4 spaces would give me $1. 2, 3. Another 4 spaces would make $2. Then $3. And $4. And then $5. I think your guys will get up to like 6 or 7 if you go the whole way across. And all this is that I'm counting by 25 cents and then 50 cents and then 75 cents and then that's $1. So it's not that I'm like just picking random numbers. I'm counting by quarters. I'm just not writing all of them down because it's kind of obnoxious. And then to decide my scale on my Y's, I want to make sure that I get at least as high as my highest data point. I want to get at least that high. So if I need to count by cut up to over 500, should I count by ones? No. I probably shouldn't even count by fives because I need to get all the way up to like 500 or more. You could count by, well, if you count by tens, you would need 50 boxes. I don't think you guys have 50 boxes there. I know I sure don't. If you count by 20s, maybe. You can count by 50s. You can count by 30s. I think I'm going to do 50s just because my graph is a little shorter than yours, but you guys can count by whatever you feel fit to do. So I'm going to count this as 50 and 100. And then I'm going to skip count here and do 200, 300, whoop, 400, 500, 600, etc. Do all of our graphs have to be identically 100% perfect and matching? If you want to count by 30s, go for it. If you want to count by 40s, go for it. If you want to count the bottom by 5 spaces to $1 and count by 20 cents, go for it. There's not a wrong way to graph as long as you count by something. It has to count by something. The one thing I can't do, I'm going to draw this up here on the inside. This is a don't do, is label this as 140, and then this one has 400, and then this one has 530. I got those numbers from the table of my data. Never, ever, ever pull your data from your table as your scale. You have to get your scale and then use the data, not the other way around. So what we're going to do is we're going to take this table of information and we're going to graph our supply line. So what that means is I'm going to relate the number of dolls supplied per week per store. So the number of dolls they get versus the price. So these are my values. So I'm going to use these to make XY points. So when the doll is $1, each store got 35. So when we go to our graph, we go to our $1, and we're going to put a point at about 35 dolls. We are estimating, we're getting it close as we can. But we're going to put it right there at 35. Our next information was that at $2, each store got 130. So somewhere up here-ish. And then our next data point was at $4. Each store got 320 dolls. And what this tells me is that on this line is where all of the kind of options are for our supplies. We can use this to predict how many dolls each store would get at any given price point, the number that they can make. So it did say when we were graphing our stuff to label this as our supply line. And then we're going to do the same thing for our demand. But what's tricky about that when we look at this table, because this was supply. When we're looking at our demand, what we're looking at are the number that are requested per store in relation to the price. So we're going to have to jump over that column to make our demand. So these two pieces are going to make our demand line. So let's do that. We're going to plot them up. When the dolls cost $1, we have 530 people that want that doll. So somewhere around there. When the dolls cost $2, I've got 400 people that want it. And when the dolls cost $4, only 140 people want it because they're going, it's a little much for a doll from the burger restaurant. In the pink bucket right by my trash can, it's a roll of toilet paper, but on my desk. Reach your right hand out to the pink flower pot. There you go. So we've got our dots up here. And what we're going to do is we're going to connect them up. And then we're going to label this as our demand line. So this is my demand. So this is hopefully familiar to you guys from econ. If not, it's a preview of what you're going to do in econ. And what we're going to do next is we are going to analyze our graph as it is. And then we're going to start using, and we might not get to it today, might do it tomorrow, using our solving systems to find our exact point of equilibrium. So our first question that we have is on the next page. If they set the price at $2.50 per doll, how many disappointed customers will each store have? Meaning how many people that want it on the demand won't get it based on our supply. So I'm going to come over here. And now I have a digital version of the graph because it's way easier to read than my handwriting. Oh my gosh. It's the same graph. I just plotted it on Desmos. So if they set the price at $2.50 per doll, they're really asking two things here. How many people want the doll if they set the price at $2.50? About. Remember, this is our price down here. So look at your demand. About how many people want the doll if it costs $2.50? Remember, this is our price down here. So if it costs about $2.50, how many people want this doll? Yeah, a little more than 300. Yeah, maybe 350, maybe 325. Depends on how good our graph is. So let's go like 325-ish. I don't know. Maybe 350. Mine looks slightly below 50, but maybe it's 340. I don't know. We're guessing. We're getting it close. So 325 people want the doll. How many does the store actually get? What is the supply at the store? Yeah, 150-ish, maybe 175. We can use 150. What we're looking at is where these two pieces of information are crossing our 250 line here. So we had our demand here and our supply here. So how many people that want dolls won't get them? There will be how many disappointed customers? How many people that want dolls don't get them? What's the difference between my supply and my demand? Say it again.
The supply is lower than the demand.
The supply is lower than my demand. So how many people won't get dolls when they want them? Because my demand is high. I got a lot of people that want them, but my supply is a little bit low. So how many people are going to be in here in between? How'd you figure that out? Subtracted the demand and the supply. So we have about 175 disappointed people. And what that was asking is what is the difference between our supply and demand? We have a bunch of people in here that really wanted the doll, but they didn't have enough at the store. So let's look at another situation. Now we're going to say, what if they set the price at $3.80? Weird, but okay. It's a weird unit. So we're gonna look very, very similarly, but this time we're looking at 380, which for me is about here. So if they set the price that high, what's our supply? How many people or how many dolls are we getting? Let's see if I can make this. Here we go. We're looking at our green one here. So on our supply, at $3.80, about how many dolls are we getting? About 300. We're estimating here, reading off the graph. What is our demand at that price? How many people want the dolls at that price? Yeah, about maybe 140. So this time I'm not going to have disappointed people, but I'm going to have extra stock. How many extra dolls will the store have? About 260 extra dolls. Which, if you think about this in terms of business, in terms of a promotion, if every week they get 250 some odd extra dolls, they're going to run out of space real fast. So they definitely don't want to have too many extra dolls in the building. But then again, they also don't want 175 disappointed people. So when you're running a business, really, you kind of want to look for where you have the minimal number of disappointed people and not too much extra stock. Not quite what they're asking us next, but it's just a good point for us to talk about. So then they're giving us a couple of theoreticals here. If they were to give these dolls away for free, how many dolls would they need? What is the price if they're giving it away for free? What price is free, y'all? Zero. When the cost is zero, how many people want it? How many people are demanding it? No, 1,070. Yeah, maybe about 650. It's where our demand is our y-intercept. Oops. It's up here. When price is zero, I'd say about 650 people would want the doll. That's the problem with free giveaways. Not everybody wants the dang doll, even if it's free. What price, according to our graph, makes the requested number of dolls be zero? So at what point did everybody go, I'm not willing to pay that much for a doll for a burger chain? At what price does everybody go, nope? Yeah, like 5. Maybe a little bit higher. Mine looks like it's slightly higher. Maybe it's 5.10. I don't know. Nobody wants that doll. So then what we're going to do is we're going to look for that sweet spot. We want that perfection. Yes, dear. 264 B. Oh, we took the difference between our supply and our demand. Yes, it would be 160. Boop. Bless you. That's not a 1. Yep, 160. It was the difference between our supply and our demand here. 160. Okay. So our last piece for this one today is we're going to look for the sweet spot where I don't have too many disappointed customers. I also don't wind up with a room full of dolls because that's terrifying. So what price-ish is going to be kind of my sweet spot? Where are we going to have nobody up, nobody mad, and not a room full of creepy dolls? Yeah. We're looking right for our intersection. We're looking for our solution. We're looking for the place where they cross. So somewhere maybe just a little north of 3. Maybe 325, maybe 310. Somewhere around there, maybe 315. I don't know. We don't have the details from that. From a picture, it's really hard to get details about that. So maybe I'm going to say 325. I'd rather have a room full of creepy dolls than disappointed customers. So maybe 325, but it's 325-ish. I don't have enough data to get an exact price. I would really like to have an exact price because then I don't wind up with a room full of creepy dolls. That's exactly what we're going to do tomorrow. We're going to take this graph that you made today. And tomorrow, we are going to write the equations for them, and we are going to solve them as a system. When we are doing this on graphing, it's really, really hard to get proper, detailed, accurate answers for things like where they cross. So now that we have this picture, now that we can kind of see what's going on, tomorrow we're going to write our equations for our story, and we're going to solve them. Okay? There we go. So, homework 3 is based off of, not the next page, but the page after, page 49. So if you need space to work for homework 3, page 49 is your place. It's got the same questions, but you do got to submit it on Canvas. Okay? Ooh, dropping stuff. All right? So that's also, I believe, going to be part of our e-learning lesson on Thursday. Technically, you do have school Thursday. You have e-learning on Thursday. And then Friday we don't have school. And Monday we don't have school. Yes. Okay. So, also, I'm out on Wednesday as well because I have a training. So we're gonna have some pretty good. It's a pretty chill week. So tomorrow we're gonna work through the rest of this, and then Wednesday and Thursday you have online assignments on Canvas, and so you'll have the whole time in here to work on them. So what do we got? And then next week we have just 2 or 3 days of stuff, and then I'll get you guys your project, and we'll have about a week to work on the project. It's kind of a packet vibe for the project. Okay. So there are 10 minutes left in the period. Do the thing. Make sure you go back and catch any missing homework that you might have. I'm going to get grades submitted by the end of school tomorrow. So if you want it to be different than it is for progress reports, which are going to get pulled on Tuesday night or Wednesday morning, depends on when they're in the mood. Anything you want in before progress report, you got to get in before tomorrow. Or before the end of day tomorrow. Before the end of school tomorrow. not midnight, because they could pull grades as early as 3. It's not common, but it can happen. Okay, so check up on stuff, do the thing. You got 10 minutes to the end of the